don't have a date though, right? No, you don't have to worry about it then.
Unless you're going to wear it yourself.
Yeah.
In which case you may just want to get a boutonniere, which is the male equivalent.
Boutonniere.
They look the
That's what it's
same.
called.
What is it called?
Boutonniere.
Yeah, I should have said. I was like, yeah.
Yeah, you need one of those too. You got to get matching hair, right?
Which you're getting one.
Okay, so you have to do the integral of cos cubed x dx. You can't do a u substitution because there's no sine x there, right? Like you said, u cubed, but then you've got 3, u squared dx, so there's no sine in there, right?
So we can't do u substitution. Right, because if you did u is equal to cos x, then du would be minus sine x dx, and there is no sine x in there, right? So, okay, so no u substitution for us. If we had a power of sine, we would need a cos factor, right? So we have a power of cos, we need a sine. If we have a power of sine, we need a cos. So if we had a power of sine, then we would need a cos. Neither of which we have. But we can do this. So we could say, all right, cos cubed x is equal to cos squared x times cos x. All right, so let's just deal with the cos cubed for now, right? We're not going to worry about the integral. We'll bring that back in. And what's cos squared equal to? The most basic trig identity. 1 minus sine squared, right? All right, so let's just string this. So at this point, if we let u equal sine x, then when we do du, we're going to get the cos x that we need, right? So let's do that. So now, let u equal sine x, then du is cos x dx. So if we go back to the integral, right? Not long enough x. So if we go back to cos cubed x dx, which is equal to the integral of cos squared x cos x dx, which is equal to the integral of 1 minus sine squared x times cos x dx. Let's extend this a smidge. Okay, which is equal to 1 minus u squared and cos x dx. That's just du. And this is easy to do, right? It's just equal to u minus 1/3 u cubed plus c. And at this point, we resubstitute, right? So we say, well, this wasn't all about u, it was about cos. And u, well, that's sine x, so it's sine x minus 1/3 sine cubed x plus c. Okay, so we're using trig identities here. There is a thing called trigonometric substitution. We're not actually, you'll do that next year, for sure. Okay, because we didn't do the derivatives of the inverse trig functions like sine inverse, sometimes called arc sine, and cos inverse called arc cos, and tan inverse called arc tan. So we didn't do any of those. So we're not about to now. So here's what we have to do then. We want to write an integrand involving powers of sine and cosine so that we have only one sine or cosine. So we want to write an integrand
involving powers of sine and cosine so that we have only one sine or cosine. Generally, that's going to be the thing with the dx, right? So we have like a sine x dx, and then when we do our u substitution, that's going to end up being du. So we have only one sine, and the remainder in terms of, so if we have a sine, only one sine, the remainder needs to be in terms of cosine. And if we have cosine, then the remainder needs to be in terms of sine. Right? So we get it, so we have a single sine or a single cosine. And if we have a single sine, then the rest of the thing is in terms of cos, because then we let u equal cos x, and then du is sine x dx, and that means we've got that sine x and so on. It'll actually be minus sine x, but you know, we can always throw the minus out front. Now there's various cases we need to look at, and so we'll do a few. We got, no, it takes a lot of room. So we'll do this on a separate page. Okay, so for example, I have sine to the fifth x cos squared x dx. So if we look at that, we say, well, I've got sine to the fifth. I can isolate one of those sines, right? And then have another one that's an even power. So we're going to take sine to the fifth x and write it as sine to the fourth x. Actually, no, here, let's do this. Let's go over here. So we'll do some stuff over here, right? We'll take sine to the fifth x cos squared x and write that as sine squared x squared. What's sine x? What's sine squared squared? Sine to the fourth, right? Times cos squared x times sine x. Okay, so if we have an odd power, then we can express that as an even power times 1, right? Sine x to the power of 1. So now, the sine squared can be replaced with 1 minus cos squared x. And that's squared, right? Which we can do, right? We can square that. And then this is times cos squared x, and then we've got the 1 sine x, right? Which is what we want, just a single sine x, everything else expressed in terms of cosine. So then we say, okay, let u equal cos x. Then du, what's du? Minus sine x dx. Okay, go back over here. So this integral, well, it's the integral of, okay, what have we got? So let's do the substitution. 1 minus cos squared x squared times cos squared x times sine x dx. Which is, now we can substitute, right? 1 minus u squared squared times u squared times negative du. Right? So sine x dx, sorry, negative sine x dx is du, so negative du is negative sine x dx. And from there, we can now just expand this. So that's going to be 1 minus 2u squared plus u to the fourth, just squaring this, right? So imagine foiling it out. 1 minus u squared minus another u squared plus u to the fourth times u squared. And yeah, we need to get rid of the negative at some point. So I could just put the negative out front here, right?
Or I can leave it there. Well, I don't know. What do you want? Let's move it up front. Let's leave it there. Okay, so let's multiply this up, right? We're just going to get u squared. Actually, you know what? Let's do that and take the negative, right? So we're going to take the negative with the u squared. So let's group this. Let's write that as negative u squared du. That makes sense, right? So when I go in here, we get negative u squared plus 2u to the 4th minus u to the 6th du. And so we could take the integral of that, right? So what do we get? What's this one become? Increase this by 1 and then divide by that. So negative 1/3 u cubed plus, what's next?
2/5.
2/5, 2/5 minus 1/7. And at the end, the ubiquitous plus c. Now, what's u? U is cos x. So finally, negative 1/3 cos cubed x plus 2/5 cos to the 5th x minus 1/7 cos to the 7th x plus c. Okay, so if we have an odd power, we then express that as some even power, which allows us to replace the squared, right? So if we express it as to the power of 6 or something, we can replace that as like sine squared x to the cube. Replace the sine squared with 1 minus cos squared, right? And the idea is take the odd power, express it as an even power, times a single of the other persuasion, or a single of, in this case when it was cos to the power, plus a single, or what was it, sine to the power? What was it? That was sine. Okay, so get a single sine x, get everything in terms of cos, use your identities, and away you go. So that's odd powers. What if we get even powers? That works for odd. And we'll summarize this at the end. What about even? Okay, so if we have even, then we want to use, so we're going to go to our formula sheet, which says that cos 2x is equal to 2 cos squared x minus 1. So if I have a cos squared, what can I replace it with? Well, let's solve this for cos squared, right? So then that's going to be 2 cos squared x, just move this over, is cos 2x plus 1, and so cos squared x is equal to 1/2 of that, and let's just write it as 1 plus cos 2x. So if you have an even power of cos, right, if all we have is even powers, you have an even power, you're going to replace it with this. If you have an even power of sine, then we'll write cos 2x as 1 minus 2 sine squared x, which means that 2 sine squared x, I'll move that over, is 1 minus cos 2x, and sine squared x is 1/2 1 minus cos 2x. Okay, so get used to doing that. I don't believe it's on the formula sheet. They don't give you cos squared equals, but this is how you're going to develop it. If I have a cos squared, 2 lines, and I can replace it, right? Because you are given these guys on your formula sheet. So you can always take the cos 2x. I got sine squared x. What the heck is sine squared x, right? I need that as like 1/2. So that's done like this. So what if we have to, let's evaluate an even power, right? I'll give you a moment to, I think we can squeeze this on this page. Evaluate. Zero to pi, sine squared x dx. Okay, so this is not going to involve a u substitution, right? I mean, what is going to involve is that we're going to write this as 0 to pi. Okay, what's sine squared x equal to? 1/2 1 minus cos 2x. So that's our sine squared x, right? Replaced with 1/2 of 1 minus cos 2x. Which is equal to, okay, so we can do the integral of that, right? I mean, just, should we do one more line? Let's do one more line. So let's just distribute the half in there. Okay, what's the, what's this? Integral. Half x, right? 1/2 x. And what's this? And this, you're kind of doing a u substitution in your head, right? But I mean, but we did this before we even knew about u substitutions. So you say, well, how do I get a cos 2x? Do a sine 2x. Then what about that half? Oh, but wait, what's the, well, it's going to be 2 times sine 2x, so it just is. So what about the half? Do I have to do anything? Quarter. Sure. Yeah, be like 1/4, right? So what's the derivative of sine 2x? It's cos 2x times 2. Okay, well, multiply this by 2, you're going to get a half. And we are going to evaluate that from 0 to pi. So 1/2 pi minus 1/4 of sine 2 pi minus 1/2 times 0 minus 1/4 sine 0. Okay, well, what's the sine of 0? 0. What's 1/2 times 0? 0. What's the sine of 2 pi? 0. What are we left with? 1/2 pi. Okay, now I crossed those out, but let's write them in, right? They are zeros. Okay. Next. Let's throw a little. Cos to the 4th 2x dx. So let's write that as so if we have an even power cos to the 4th, we can write that as cos squared 2x. Oh, and wait, it's a definite integral, so it's going 0 to pi. Well, what's cos squared replaced by? Cos squared x is 1/2 1 plus cos 2x. Okay, so 1/2 times 1 plus cos 2x, which in this case is going to be the cos of 2 times 2x, right? So it's the cos of that, right? It's double this. and that's squared. Which is, well, if we square the half, we're going to get a 1/4, right? And I'm just going to move, it's a constant, so I'm just going to move it out front, right? 1/4. That's that half squared. If we square this, we get 1. Okay, so squaring that, I do an imaginary FOIL when I square these things, right? So I think 1 plus cos 4x plus another plus 2 cosine 4x plus cos squared 4x dx. So we got another one of these cos squareds with something in here, right? Well, what do we do with the cos squared of something? We go a half of 1 plus the cos of double whatever's in here. So in this case, cos squared 4x is going to be replaced with 1/2 1 plus cos 8x. Okay, so we'll get rid of that cos squared and then just give us something that's easy to, so 1/4 1 plus 2 cos 4x plus 1/2 1 plus cos 8x dx, right? So again, we've gone back, and it's just going back to here. Cos squared of something is a half times 1 plus the cos of 2 times that something, right? So in this case, when we've got cos squared 4x, it's a half 1 plus the cos of 2 times 4x, which is 8x, okay? So once you've got this here, right, then it's easy to do cos squared of anything, right? Just keeping in mind that you're going to write it out like this and just double the anything. Okay, so it'll be 2 anythings. Too far. Okay. Oh wait, and there's an integral in there, and it's definitely from 0 to pi. All right, so what have we got? Well, let's take our time. That's too many brackets there. So we've got 1 plus 1/2, which will be 3/2. Plus 2 cos 4x plus 1/2 cos 8x dx. Okay, now I think we're ready to find the integral. I just extend this back down a bit. Okay, so it's 1/4 times 3/2 integral. Two cos 4x. Like doing a u substitution in here, right? So it's going to be sine 4x. What's the derivative of sine 4x? 4 cos 4x, right? But we want a 2, so we're going to have to throw in a half. Right? 1/2 sine 4x. Okay. What's next? Cos 8x. So it's going to be sine 8x, but the derivative of sine 8x is 8 times cos 8x. So we're going to need 1/16. So we multiply that by 8, we'll get a half. And we're going to evaluate that from 0 to pi. What's the sine of 4 pi? 0. What's the sine of 8 pi? What's the sine of 0? 0. So all these guys, right? I mean, when I put in sine 4 pi, that's going to be 0. When I go 1/16 sine of 8 pi, it's going to be 0. When I put the zeros in, it's going to be sine of 0, which is also 0, right? So these guys really, you know, it's really just 1/4 of 3/2. Okay, but let's do it. Okay, so if we do the full substitution, right, it's 1/4 of 3 pi over 2 plus 1/2 sine 4 pi, which is going to be 0, plus 1/16 sine 8 pi, which is going to be 0, minus 3/2 times 0, which is going to be 0, plus 1/2 sine 0, which is going to be 0, plus 1/16 sine 0, which is going to be 0. So the only thing that's not 0 is the 3 pi over 2. So 1 times 3 pi and 4 times 2. So 3 pi over 8, or 3/8 pi, is what we get. It was positive. Okay, so if you want to evaluate sine to the mx, cos to the nx, if the power of cosine is odd, and what makes an odd number? It's an even number plus 1, right? So if n can be written in the form of 2 times any number plus 1, it's going to be odd, right? Because 2 times a number is by definition even, and then you add 1, so you make it odd. Then you want one cosine factor, and use cos squared x is 1 minus sine squared x to replace the remaining even factor. And express things in terms of sine. In terms of sine x. Okay, so it'll look like this. Okay, so you've got cos to the 2k plus 1. You split that up as cos squared to the k. What does that give you? Cos to the 2k, right? Multiplying powers the same base. Power to a power, you multiply the exponents. And then this cos 1, so then if you multiply these two guys, you get 2k plus 1. So that's how you split the 2k. You'd split it into an even power, which you write as cos squared to something. So if it was 6, it'd be cos squared cubed, right? If that was a 7 originally, then you'd have that there. You then convert that, so you've got sine. This becomes 1 minus sine squared to the power of k times cos x dx. And you let u equal sine x, and then you continue from there. Okay? So you get u equals sine x, so you've got a u substitution. This can be multiplied by this, blah, blah, blah. The cos x dx becomes, because then what do you get out of that? You get du is cos x dx. So this becomes your du, and all of this is in terms of u, and away you go. If the power of sine is odd, you do the exact same thing, only with sine, right? So I'm not even going to write that out. So if the power of sine is odd, then m is equal to 2k plus 1. You express it. So you've got a single sine. You let u equal cos x, and then du becomes minus sine x. Do you want me to write it out, or no? Okay. So just what you see there, replace this with an m. Replace that with, and everywhere you see sine, write cos, everywhere you see cos, write sine. If they are both even, use the half angle identities. Okay, so sine squared x is 1/2, 1 minus cos 2x, and cos squared x is 1/2, 1 plus cos 2x. Okay, and those you can develop on your own. They're not given to you. You don't have to memorize them. You can do it within 2 steps from the cos 2x stuff, right? And one thing that comes in handy is just remember that cos squared of 2x is 1/2, 1 plus cos 4x, right? So if you're doubling this, then you double this, right? Because you're going to see this appear a bunch of times, right? Especially if you replace both of these guys, if you had to do sine squared x, cos squared x, you multiplied these together, you got 1/4, and then you've got really a difference of squares, right? You're going to have with 1 minus cos squared 2x, which you're then going to replace with this, and it'll give you something that's then reasonably easy to do. Okay, so there's, the bell goes.